Okay, now we have come to maximum minimum problems. Basically problems in real world. And usually problems, they will have diagrams for you to look at. Let's highlight some keywords in the question. Okay, important thing is I need to know what are the formulas of volume, surface area, of cone, and cylinder. For part, you can look at the clues in the question. What they give you? They give you volume, 60 centimeters cube. Okay? Now, since I know it's volume 60 centimeter cube, let's write the first equation. Okay, so basically I just add the volume of cone with the volume of the cylinder equals 60. Let's solve for H. Make H the subject. Okay, after some manipulation, I finally show that H is what they want us to show. Okay, then we can do our part 2. Now part 2, they show surface area. Total surface area is this. Let's just write the equation for surface area first, step by step. I realize that my A has a H, which my final answer that they want to show don't have. So I'm just going to replace the H. My H is already found in part 1. So after replacing H with the answer in part I, and after some manipulation, you are able to show A is as such. Okay, part 1 and part 2 is supposed to help for part 3. Let's say if you don't want to do part 1, part 2, it's okay. They really give you the answer for H and A. So let's just focus on the main part of the video, part 3. Keyword, stationary value. So you can link it to stationary points. And stationary points, my gradient is 0. In this case, it's not dy over dx. It's actually my dA over dr. Okay, because these are the numbers, these are the unknowns that we're looking at. dA over dr equals to 0. Okay, part 3. What is the first thing that you will do for part 3 to get your first mark? First mark you differentiate, you will get from this equation. This is my first equation. We will find dA over dr. After I find dA over dr, next step, equate it to 0. Okay, equate it to 0 and then just start solving for your r. So you will find your r value, which is one of your answers. Now let's determine whether this r value will give me maximum or minimum. Okay, let's do the first derivative test at the side. Okay, remember for first derivative, you have to sub it into the dy dx. And you'll realize that it's this one. Maximum or minimum? If I write like this, it will be a maximum. As I said, I give you a hint. This is a 4-mark question. So far, 1 mark for differentiation, 1 mark for finding r, 1 mark for proving that it's maximum. There's 1 more mark missing. What is the 1 mark? The last one is stationary value of A, which means you have to calculate area. Basically, sub this into the equation of A. Okay, you'll find that your maximum area is 65.1 cm squared. Okay, so by mistake, this will be less than 0, this will be more than 0. Okay, so let's say if I verify this mistake, okay, let's say you have a mistake. What you have to change is, okay, just change your maximum to minimum. Okay, and that's the corrected mistake. Okay, and the last mark will be your A, which will be the minimum.